In the previous video on equity valuation, I discussed and worked a problem of calculating the intrinsic value of a stock based on a constant growth model, dividend growth model. In this video, I'm going to start off by talking about different life cycle and multi-stage growth models where we don't assume that the dividend is going to grow at a given constant rate over time. So what I have here, it says most firms have non-constant growth in future earnings and dividends. So we need to use multi-stage models for these firms. For many firms, practitioners assume the growth has 3 stages, which are characterized as follows. Firms often try to extend their growth phase using changes in strategy or business mix. So oftentimes, when a company first starts off, they've got a single product, and it'll get to a point where they've saturated the market with that product to the extent that they can. And so then they'll start to diversify that product a little bit, maybe adding features, maybe changing it, maybe offering different varieties of the product or service that they offer. Sometimes companies go out and diversify by buying other businesses or creating other products or services that they can sell, and they do this in an effort to extend their life cycle, and especially the growth stage of their life cycle. And so what I have here, it says technology also may also change the duration of that growth cycle. Nevertheless, the 3 stages here are a useful approximation of a firm's for many firms' phases. And so what we see here in the equations is that we have a phase of non-constant growth. So what this says is that we're finding the intrinsic value of the firm, V sub 0, or the stock, is equal to all of the future dividends discounted back at the required rate of return for equity. And this second portion of the equation says that the value of the stock today is equal to the sum of all of the future dividends from time 1 through time h, and then we're going to find the value at time h. And the value at time h is the horizon value, and the horizon value occurs where the constant growth begins for the company. So the horizon value or horizon time period occurs and oftentimes that constant growth period starts when the company has reached its full maturity, where it's fully saturated the markets with its product or service, and growth for the company then is restricted to growth in the population and growth in growth in sales due to inflation. So an example we're going to look at later on is Coca-Cola. Coca-Cola really fits this definition well of a company that has fully saturated the market with its goods and services, where it doesn't really have additional markets to grow into, except for if Coca-Cola, for example, would choose to invest and buy other companies engaged in other services or products. And in that way, they could possibly extend or maybe reinvigorate their growth cycle at that point. But barring acquiring another firm or doing some other form of diversification, Coca-Cola has really saturated the market, and they would be generally considered to be a constant growth company. And we'll take a look at them later. But for now, let's look at a few examples of non-constant growth. So we've got an example here of ABC Inc. ABC Inc.'s last annual dividend was $2.50. Management expects the dividend to grow by 9% for the next 3 years and then by 4.5% thereafter. If the cost of equity for this firm is 12%, what is the value of the stock today? So in order to determine the value of the stock today, we would need to project out all of the future dividends between now and the horizon period. The horizon period is going to be 3 years away, because what it says here is that management expects the dividend to grow by 9% for the next 3 years and then 4.5% thereafter, meaning that there's not a limit to the company's growth after that 3-year period, that the growth rate, though, is going to be 4.5% per year. So let's go ahead and work that out. I'm going to use Excel here to work through this example. So the problem said that the last dividend paid was $2.50. So that's what we're going to start with. So our last dividend was $2.50. And that's an annual dividend. So that's the amount that was paid out over the year. And then I'm going to put down here the year, the discount rate, or the growth rate, and then the cash flow. Okay, and the cash flows in this case are going to be dividends. Later on, we're going to change the definition of the cash flow to be the free cash flow to the firm or the free cash flow to the equity holder. But for now, we're just going to use the dividends as our cash flow. So we're going to have year 0, year 1, year 2, year 3, and year 4. At time 0, for time 1, our growth rate is 9%. So I'm going to put in 0.09. Time 2, it's 9%, and then time 3, it's 9%. And then at time 4, it's actually switching at the end of time 3 to 4.5%. Because that's where the constant growth begins, our horizon period is going to be time 3. Okay? We're going to work at other examples where we change that horizon period just so you can see how that works. But for now, because that's where the constant growth starts at the end of time 3, we're going to value the stock at time 3 using the constant growth model. So our cash flows at time 1, we expect to receive a dividend that's equal to the last annual dividend paid multiplied by 1 plus the growth rate of 9%. And so, rounding it, it's $2.73. The next year, I'm going to take the dividend from time 1 or year 1. I'm going to multiply that by 1 plus the growth rate. There we go. So it's $2.97. And then year 3, we're going to increase the dividend again. And then finally, year 4, and you can actually, at time 2, you can do this as well, but you could just drag this over. And we see that the expected dividend for year 4 is $3.38. Okay. So those are our expected dividends for the next 3 years. I'm going to go back out here and look at the equation that I have. And what the equation says is that, and I apologize, I need to make a correction here. So what the equation here says is that the value at the horizon time period, time h, is equal to the dividend at time h plus 1 divided by the required rate of return minus the constant growth rate. I'm going to just scroll up for a minute. I'm going to show you where this comes from. If you remember the constant growth model, this is the same as the constant growth model, where we have, and these should be R's. Let me fix that really quick. So where we have here the dividend, the value at time 0 here is equal to the dividend at time 1, or the last annual dividend paid multiplied by 1 plus the growth rate, divided by the required rate of return minus the growth rate. So that's the same thing we're looking at here. We're looking at the value at time h is equal to the dividend at time h plus 1. So in the example we're working, it is the dividend at time 3 plus 1 year. So the dividend at time 4 divided by the required rate of return minus the growth rate. And that's our value at the horizon period. Okay, so I'm going to go back out here to the spreadsheet. So my horizon value is equal to the dividend at time 4, so that's equal to 3.38 divided by the required rate of return. The required rate of return for this stock, according to the problem, is 12%. So I'll put 0.12 minus the constant growth rate of 4.5%. So according to this, we will, if we bought this stock today, we would expect to receive a dividend of $2.73 at time 1, a dividend of $2.97 at time 2, a dividend of $3.24 at time 3, and then at the end of time 3, we can sell the stock for $45.11. We don't include the $3.38 in our calculation because that's included in the $45.11 we expect to receive at the end of time 3. So now what I'm going to do is I'm going to take my cash flows I expect to receive. I'm going to find the present value of those in Excel using the NPV function. So we're going to calculate the value of the stock today by using the net present value or NPV function in Excel. So here I'm going to put equals NPV. The rate is going to be my discount rate. My required rate of return in this case is 12%. Then I'm going to put a comma, and then I'm going to highlight my 3 values here. The last one being the dividend at time 3 plus the horizon value at time 3, 40, and those together is 48.35. Close parentheses and then enter. And so we get a value today, or an intrinsic value today, of $39.21, which is what we would estimate the value of the stock to be. So the answer here is $39.21. The next question has 2-step growth, and this is just an example of having more than just like 9% for 3 years. We have more years that we're going to look at here, and so I'm also showing you this because we have a different horizon period then. And so here it says the XYZ's last annual dividend was $4. So our dividend at time 0 is $4. Management expects the dividend to grow by 20% for the first 2 years, 10% for the next 2 years, and then 5% thereafter. If the cost of equity for this firm is 15%, what is the value of the stock today? So the cost of equity is the required rate of return for the stock. So I'm going to go out here. I'm going to do the same setup. I've got the year, I've got the growth rate and the cash flows, and the last dividend paid. So I'm just going to actually copy this. Actually, I'll just copy the first part here. So I'll go down here and start a new problem. So our last dividend paid was $4. We're going to need 5 years here because we're going to have 2 years of growth at 20%, 2 years at 10%, and then after that we expect continuous growth at 5% per year. The growth rate for the first year is 20%, for the second is 20% or 0.2, for the third year is 0.1, for the fourth year is 0.1, and then after year 4 we expect a 5% growth rate for the foreseeable future at that point. Our cash flows are going to be our dividends. So for year 1 we're going to take the $4, which was our last dividend paid. We're going to multiply that by 1 plus the growth rate, and you can see I put that in parentheses there. If I don't, I get something. I would actually get 4 plus 0.2, which would be the wrong answer. So here we get $4.80. For the next year, I'm going to put in equals, and then highlight the year 1 cash flow, multiply that by 1 plus the growth rate at year 2, and then after this point, I can just drag that formula over to year 5. Now the reason I don't put the $4 down here at time 0 is because I don't want to include that in my value today. I don't want to include the last annual dividend paid in my value for the stock today because it's already been paid. So if I bought the stock today, I wouldn't receive that $4. It's already been paid out. And so that's why I'm not including that in my calculation for the value today. Our horizon period here is going to be time 4, and it's time 4 because that's where our constant growth starts. The constant growth rate between years 4 and 5 is well, actually for year 5 is 5%, and so I can calculate my horizon value at year 4. I cannot calculate my horizon value at year 3 or year 2 or year 1 because we don't have constant growth at that point. We can only calculate it where we have the constant growth begin. So I'll calculate my horizon value here. It's going to be equal to my dividend for the next time period, year 5, divided by the required rate of return. And in this case, my required rate of return is 15%. It's my cost of equity, 0.15. And from that, I'm going to subtract out the constant growth rate of 5%. So that's going to give me a value, my horizon value of $73.18. And so at time 4, if I bought the stock today, I could sell the stock, in theory, for $73.18 at time 4. And I expect for year 4 to receive a dividend of $6.97. I add those two cash flows together, I get $80.15. Now, it doesn't actually matter when I expect to sell the stock. Okay, this is just telling me that what's expected in terms of cash flows for each time period for that stock. I could buy the stock today and sell it tomorrow, or I could wait 20 years to sell it. That doesn't change the value of the stock. So I've got my cash flows here, $4.80 at time 1. That's the dividend I expect to receive. I expect for time 2 or year 2 to receive dividends of $5.76. And then at time 3, I expect to receive dividends of $6.34. At time 4, I expect that the firm's going to pay dividends of $6.97, and then I can sell the stock for $73.18 at that point in time. So my value today is going to be equal to the net present value, NPV. The rate is 15%. And then I'm going to highlight my cash flows there, so it looks like that. So my value, the value of this stock today is estimated to be $58.52. Okay. So this next one, I like to show it because it uses the price to earnings ratio, or the expected price to earnings ratio, to calculate the horizon value. We're going to work through this problem using the constant growth model, and then we're going to use the price to earnings ratio to calculate the horizon value. So in the first example, we're going to ignore the price to earnings ratio. We're going to use that down below to calculate the value. For now, we're just going to use this as an example of a two-step problem, or a one-step growth problem. So the current dividend, or the last annual dividend paid, is $2. The growth for the next 3 years is expected to be 15%, and the long-term growth, or the constant growth, is expected to be 4%. The required rate of return, or the cost of equity, is 10%. So again, in Excel, I'm going to use my same setup that I have before. Just going to copy this down, and then we're going to move it down a little bit for another problem. So the last annual dividend paid was $2, or the current dividend as I have it in the problem. And then we have 3 years of non-constant growth and then constant growth. So I'm going to put 4 years out here. So I'm going to put time 0, and time 0, or year 0, is today. I expect that it's going to, the dividend is going to grow by 15% for the next 3 years, and then 4% thereafter. And so we calculate the dividends just like we did before. We take the last dividend paid, annual dividend paid, multiplied by 1 plus the growth rate. I'm going to do that at year 2. So we're going to take the $2.30 from year 1 and multiply that by 1 plus the growth rate of 15% for year 2. And then I'm going to drag that over. My horizon period here is year 3 because that's where constant growth starts. We have a 4% growth rate at year 4 for year 4. So this is my horizon period. And so my value, my horizon value at year 3 is equal to the 3.16 divided by the required rate of return, in this case, is 10%, so 0.10. And our constant growth rate is 4%. And so that's going to give me a horizon value of 52.72. So our cash flows look like this. For time 1, I expect to receive a dividend. Oops, I'm going to change that a little bit. Here we go. I'm going to receive a dividend of $2.30. At time 2, I expect to receive a dividend of $2.65. And then at time 3, I expect to receive a dividend of $3.04, and that the stock will be worth $52.72 at the end of that period. Our required rate of return here is 10%. So I'll use the NPV function, and I'm going to put in 10%, 0.10, and then highlight those 3 cash flows to get a value today of $46.17. So the reason why we might want to use a price to earnings ratio instead of that constant growth model to calculate the horizon value is because that constant growth model can be very sensitive to changes in the required rate of return and or the constant growth rate. So just going back to this example here, if I change the constant growth rate to 3% instead of 4%, and actually let me make one little change here. I'm going to put 0.03 here just to be consistent, and then use a constant growth rate of 3% down here. We can see that that has a big impact on the value of the firm. So with a growth rate of 3%, the horizon value is $44.76 compared to a value of $52.72 with a 4% growth rate. So a small change in the growth rate, a small change in the cost of equity can have a big impact on the horizon value and then the value of the stock today. If we feel pretty confident about what the price to earnings ratio should be for a firm, then we might want to use that instead to determine what the horizon value would be. So the reason why we might like that price to earnings ratio is if the industry is stable and the company has had a stable price to earnings ratio over time. If the industry, like I mentioned, has a price to earnings ratio that we feel comfortable with, that we can then assign to the company, it can provide a more stable outlook for what that price might be. So in the question I have here, it says using one-step growth with and without using the price to earnings ratio, and we calculated it without the price to earnings ratio to calculate the horizon value already, and the value we got there was $46.17. So that was our answer up here. And now it says using the trailing price to earnings ratio to determine the general two-stage dividend discount model. So we're going to use the trailing PE. What that means is that we're looking at the price at a point in time divided by the earnings for the previous 12 months. So the trailing PE is the price at a point in time divided by the earnings per share for the previous 12 months. Okay. And there's different definitions of that. It could be the last 4 quarters. It could be for the previous fiscal year end or fiscal year. For us, we're just using the previous year, what it was for the previous year. So using the previous example, we'll now use the trailing PE to determine what the terminal value is, or the horizon value. D4 is equal to 3.1634. We actually calculated that before. Let me show you. So if I push this out a little bit here, I take out the rounding, we get a dividend at time 4 of 3.1634. Okay. Now, what's in the problem? It says, assume that the projected price to earnings ratio is 13 in year 4, and the firm will pay out 60% of earnings as dividends. So whenever a company is coming up with these estimates for their dividends, how much they're going to pay out, at the same time, they're calculating out the expected earnings per share that they're going to have, because those two things go together. And so in this problem, what we're looking at is a company that has said they're going to pay out 60% of their earnings as dividends, and we've calculated the dividends here, so we can get to the earnings per share using the dividend payout ratio and the expected amount of dividends to be paid. So let me show you the calculations here. So the way we're going to get to the earnings per share is by using the information we have. We've got the dividends per share at year 4, and we've got the dividend payout ratio of 0.6. So the dividend payout ratio is equal to the dividends per share divided by the earnings per share. And what I'm trying to get to here is the earnings per share. And I know what the dividend payout ratio is. In the problem, it says the dividend payout ratio is 60% or 0.6. So here I can put in equals 0.6 is equal to the dividends per share, which I already know is 3.1634, divided by the earnings per share, which I don't know, which is what I'm trying to find. So if I'm going to calculate the earnings per share, my earnings per share are going to be equal to the 3.1634 divided by the 0.6. Okay. And so I can calculate that now. I'll go back to Excel to do that. So the earnings per share is equal to the 3.1634 divided by 0.6. So my earnings per share is 5.27 approximately. Or 5.27. And so my price to earnings ratio is 13. So I'm going to switch back to the document here just to show you the calculation here for the price, the estimated price of the stock. And this is equal to the price to earnings ratio multiplied by the earnings per share. So it's a PE multiplied by EPS and that will give us the estimated price of the stock at year 4. And so it's going to look a little bit different than what we've done previously here. So the estimated price of the stock is $68.54, but here, previously on this problem, we calculated the horizon value at time 3. We calculated at time 4 at this point because we're looking at the trailing PE. So we're looking at the point in time where the earnings per share of $5.27 that we calculated is for the trailing 12 months for when this price to earnings ratio is being calculated. If we were looking at the forward PE, where we look at the next 12 months of expected earnings, we'd actually calculate the horizon value here at time 3. But because we're looking at the trailing PE, we're using time 4. So everything here is the same. So I'm going to copy this, except for I'm going to change when that horizon happens. So our value here, our dividend at time 1 would stay the same. It's still going to be the $2.30. The dividend at time 2 is still $2.65. The dividend at time 3 is still $3.04. The dividend at time 4 is still the same as $3.1634. We take out the horizon value here. The horizon value is going to occur at time 4. We calculated this already to be $68.54. We did that again. There was a few steps there. We calculated the earnings per share based on the dividend payout ratio. And then we multiplied that earnings per share by the expected price to earnings ratio of 13. So we expect to be able to sell the stock at the end of year 4 for $68.54. So our cash flows look like this. At time 1, we expect a dividend of $2.30. At time 2, we expect a dividend of $2.65. At time 3, we expect a dividend of $3.04. At time 4, we expect a dividend of $3.16. And then we expect to be able to sell the stock at that time for $68.54. So our total cash flow at time 4 is expected to be $71.70, which is the sum of the dividend plus the horizon value. Our value today then is these cash flows discounted back at the required rate of return. And our required rate of return for this stock was 10%. So I'm going to put in here equals NPV. My rate is 10%. And then I'm going to highlight my cash flows to get a value of $55.54. Okay. So I wanted to provide some practice for you on how to calculate the price of a stock using its expected dividends in several different kind of situations there. So you can get a feel for growing the dividends and then finding the horizon value and finding the present value of the stock.